Hello everyone, my name is Snehaaigali, student of Sri Venkateshwar College of Engineering, Bangalore. Today I am up with this interesting subject called as mathematics. In that, the topics which I would be explaining for today's session would be probability distribution, binomial distribution, and the last topic would be our Poisson distribution. First up, let us go through the introduction to probability distribution. What exactly probability distribution is? Probability distributions are the mathematical functions that describe the likelihood of different outcomes in a random experiment. Two commonly used probability distributions are the binomial distribution, and next up we have the Poisson distribution. In this specially, we will be exploring about the characteristics and applications of these two distributions. Let us first go through binomial distribution. That is the basics of binomial distribution. Binomial distribution models the number of success in a fixed number of independent Bernoulli trials. It is characterized by two parameters, that is n and p. N means the number of trials and p includes probability of success within each trial. Next up is the probability mass function of the binomial distribution. It is given by P of x is equal to k, that is equal to C of n and k. Next up, we have the characteristics of binomial distribution. It includes the mean of binomial distribution is given by mu is equal to n, that is mean is equal to n. The next bullet point is the variance of binomial distribution is given by sigma squared is equal to n, that is standard deviation is given by n. Next up, let us see the applications of binomial distribution. The binomial distribution, it is commonly used in various fields which include statistics, finance, and quality control. It can be used to model outcomes such as the number of defective products in a sample, the number of successful sale calls, or the number of heads in a series of coin flips. Binomial distribution is also a fundamental component in hypothesis testing and confidence interval estimations. Next up, we have Poisson distribution. The Poisson distribution models the number of events occurring in a fixed interval of time or space. Poisson distribution is characterized by a single parameter, that is average rate of events per interval. The probability mass function of the Poisson distribution is given below, that is P of x is equal to k, which is equal to e power sigma. Next up, here we have the characteristics of Poisson distribution, that is further explanation of Poisson distribution. That is the mean of Poisson distribution is given by mu. The variance of Poisson distribution is given by sigma squared. The shape of Poisson distribution is a square to the right with a longer tail on the right side. Next up here, we have the applications of Poisson distribution. The Poisson distribution, which is commonly used in fields such as telecommunications, insurance, and queuing theory. Poisson distribution can also be used to model events such as the number of phone calls received in a cell center, the number of accidents at a particular intersection, or at the number of claims filed in an insurance company. Poisson distribution is also used in reliability engineering to model the number of failures in a given time period. Now, what is the difference between binomial distribution and Poisson distribution? Let us understand. The binomial distribution models a fixed number of trials with a probability of success, while in Poisson distribution, it models the number of events in a fixed interval. In binomial distribution, we have fixed number of trials with probability of success, whereas in Poisson distribution, we have number of events in fixed intervals. The next up is the binomial distribution is discrete and has a finite range of possible values. Whereas if coming to Poisson distribution, it is also discrete but an infinite range of possible values. In binomial distribution, we have finite range of possible values, whereas in Poisson distribution, we have infinite range of possible values. Next up is the binomial distribution has two parameters, that is n and p, while the Poisson distribution has only one parameter. Now, as we have seen the differences, now let us see what are similarities between the binomial distribution and the Poisson distribution. That is, both binomial and Poisson distributions are discrete probability distributions, as we have seen earlier. Then, both the distributions are used to model the number of events or success in a given contest. That is, in a given range, both the distributions are used to model the number of events happening. Next up, the similarity is as the number of trials n in the binomial distribution becomes larger, the probability of success, that is p, becomes small. It approaches the Poisson distribution. That is, Poisson distribution follows same law. That is, as the number of trials increases, the probability of success decreases. That is, both n and p are inversely proportional in both the cases. That is, in binomial as well as in Poisson distribution. Now, next up, a quick glance of what we learned in all three of the distribution. Probability distribution, such as the binomial and Poisson distribution, allow us to mathematically describe the likelihood of different outcomes in random experiments. The binomial distribution models the number of success in a fixed number of trials, whereas the Poisson distribution models number of events in a fixed interval. Understanding these distributions and their characteristics is essential for various applications in statistics, finance, and other fields. Well, that was all about the binomial distribution and probability distribution. Thank you so much for watching.